Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so we have reached question recall topic A, probability in this recall semesters, and let's begin our discussion of this topic with lecture 1 of 3 for the topic of 8.1 probability. Okay, so please refer to the handout that you have in your hands right now. So we're going to recall, define the concept of experiment, outcomes, and all this, the basic laws of probability, and find the probability of an event. Okay, so which I think that this topic is also part of topic that very close in our daily life. Beside the topic of 7 permutation combination, probability is also part of recall topic that very close to our life. Then, okay, suppose there are a pen, black, blue, and a red pen. So what's the chances of choosing a black pen? Okay, there are 3 of them, 1, 2, 3, and the chances of getting one of the pen which is black is 1/3. So that's the probability of choosing a black pen is 1/3. The definition of basic term in probability: a random experiment, a process leading to at least 2 possible outcomes with certainty to which they will occur. And okay, so you read it by yourself then. It's a subset, the event is a subset of basic outcomes from the sample space. Okay, so just imagine that if you have a coins, okay, if you have a coin, if you have a coin, so you can see from here there might be a picture of, recall, any pictures of flowers with a recall value that is recall printed on that, let's say 20 cents. Okay, so on the other side of this coin there's some pictures of, like, so any our historical building. Okay, so there are 2 faces that we call shows us that we call the value of the money, and also the other side is the pictures that bring up, we call the image of our country. So tossing a fair coin, the result will be either head or tail. So just imagine that this head, and on the other side we consider as a tail. So then the basic outcome, head or tail, then the sample space is H or T. Okay. Rolling the dice. So, okay. So, I do believe that all of you have ever seen this object before, a dice, when we play something games. Okay. Then one surface and a face here shows a 1 dot, meaning it's a 1. Let's say here is 4, and here 6. Okay, there are 5 faces here, 5 surfaces, then so the basic outcomes are the number 1, 2, 3, 4, 5, and 6. So this is a sample space here. A is an event of getting odd numbers. Then A equal to 1, 3, 5. Okay. It's a subset of all the sample space. That's it. Example 3. List a sample space of 2 dice are tossed, or a dice is tossed twice. Okay, you have 2 dice. Then you toss it twice then. So that the result, okay then. So look at this one here. Let's say if I have 2 dice, so dice number 1 and the other one here, the second dice or dice number 2. Okay, same thing goes to here. So then if I toss this at one time, or might be we toss it one by one, you will get 2 results. Okay, 1 and 2 and 2 and 1. We consider it as a 2 different result, because this is for D1 and this is for D2, and also this is for D1 and D2. Okay, so we consider this as a 2 different result. For 2 and 2, there's only one result then. 2 and 2 here. There's no other result for 2 and 2. So you got this. You can look at this one here. Result. The probability of this one here. 1, 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6, and 6. Okay. So with a double result, because the same result, it will only appears once only. Okay. So then the number of sample space, the result of all this is 36. So, wait. Okay, so for example 3 here, let's say let A is an event of getting a sum of 2 numbers is 6. Okay. So A equal to, so from the result of getting 6, look at this one here now. 1 plus 5 equal to 6. 2 plus 4 equal to 6. 3 and 3 equal to 6. 4 and 2 and 5 and 1. Okay, so then we list down here is a 1 and 5, 2, 4, 3, 3, 4, 2, and 5, 1. So how many results on here? 1, 2, 3, 4, 5. Then event of getting result of sum of 2 numbers is 6 equal to 5. Okay, so another example here. B event of getting a sum of 2 numbers is a multiple of 5. Okay, so then equal to multiple of 5 means that the sum of 2 numbers is multiple or divided by 5. Okay, so first one then, look at this. 1 plus 4 equal to 5. So 5 divided by 5 equal to 1. And then another result here is 4 and 1. Next, 2 and 3. 3 and 2. Okay. 5 and 5. 5 plus 5 equal to 10. 10 divided by 2. Okay. Equal to 5. 4 and 6. And 6 and 4. Okay. So you can just count by yourself the result of 1, 2, 3, 4, 5, 6, and 7. So then you list down all the results as you see here, as we discussed here. So list all of them, and the total number of the result is equal to 7. Okay, so then mutually exclusive. 2 events A and B are called mutually exclusive if there's no intersection between 2 events. Okay, meaning the event of A is not related at all with the event of B. So there are two separate cases here. Example 4. Okay, so for example 4, when we rolling a dice. Okay, so let's say we come up with the event of A. Okay, event of A getting even numbers, and B getting odd numbers. Okay, so for A, even numbers from the dice, which is 2, 4, and 6, while B is 1, 3, and 5. Okay, so say event of A here and B with 2, 4, and 6, 1, 3, 5. So between these two events, there's no numbers of what you call numbers on the dice that shared by both of A and B. There is no interception. So then, therefore, A intersect B is a set null. Then A and B are called mutually exclusive. Okay, so term of mutually exclusive here. Okay, exhaustive events, let's say event A and B are two exhaustive events if the event of A union A to two events, union of these two events give us that the whole element or set master set of the event itself equal to 1. So the example 5, okay, so let's say sample space is all the numbers digit from 1 until 10. And event A is the number of 1 until 6, and B is 5, 6, 7, 8, 9, 10. So we got two similar here. So okay, so then let's say event A union B equal to 1, 2, 3, 4, 5, and 6. And 5, 6, 7, 8, 9, 10. 7, 8, 9, 10. So that we call the result of event A union B give us all the we call the sample space for this event. Okay, for this as all the split samples here. So we call this A union B equal to S here. So then A and B are exhaustive event. So next one here, if A union B, so the sample space here 1, 2, 3, 4, 5, and 6 with A 2, 4, 6 and B 1, 3. There is no number 5 either in event A or B here. So A union B is 1, 2, 3, 4. There is no 5 here and here, but it's a 6. So 6 is not in the list either in A event A or B. So then it's not equal to the event of sample space here. So then A and B are not exhaustive event. probability of event, the probability of event. So now we'll get into the topic of probability here right now. The probability of event occurring is denoted by PA, where probability of A is number of possible outcomes and number of all possible outcomes in S. Here. Okay. So then the result of probability. The result of probability lies in between, or it can be equal to 0 and less than or equal to 1. It should be probability of A equal to 3.75. 3.75 is greater than 1. Okay. This is 0 until 1. So this is the range of the value of probability. It cannot be here or here. Okay. So this is incorrect. Okay. So probability of A equal to 1, the event of A is a sure event, and if it is 0, then event A is an impossible event. The complement probability of A bar or A dash here means that probability of A doesn't happen. Okay, example 6. When two dice are tossed, find the probability the sum of two numbers is 8 and the sum of two numbers is a prime numbers. Okay. So then again, let's see with all the result. When two dice are tossed together or we toss two dice one by one. So it's all the possibilities that will appear. Okay. From 1, 1 until 6, and 6 then the n equal to 36. So the sum of two numbers is 8. Okay. Sum of two numbers equal to 8. 2 plus 6 equal to 8. 3 plus 5 equal to 8. 4 plus 4 equal to 8. 5 plus 3 equal to 8. And 6 plus 2 equal to 8. Okay. And the sum of two numbers is a prime number. So prime numbers is numbers that can divide by 1 or itself. Okay. Okay, so now let's see the first one here. The sum of two numbers is 8. Okay. Okay, sum of two numbers equal to 8. Okay, so let A is an event with 2, 6, 3, 5, 4 and 4, 5, 3 and 6, 2. So then, the number of result of A, the possibilities of A equal to 5. So then the probability of A equal to 5 divided by the total of probability, which is equal to 36. Okay. And then B, let B event of getting two numbers. Okay. Sum of two numbers equal to prime numbers. Okay, so prime numbers, we begin, let's say 2, 3, 5. 4 can divide by 2. Nope. Okay. 6, nope. 6 you can divide exactly by 3, they give you 2. And you have 7. 8, no, 9, no, 10, no, 11, 13. Okay, so then let's take a look at this one here. The result of getting a prime numbers with 1 and 1. 1 and 2, 1 plus 2 equal to 3 here. Then 1, 4, 1, 6. 2, 1, 2, 3. 2, 1 plus 1 equal to 3. 2 plus 3 equal to 5. Okay. 2, 5 equal to 7. Then 3, 2 equal to 5. 3 plus 4 equal to 7. 4 plus 1 equal to 5. Okay, this time all 1 by 1, never mind. 4, 3, 5, 2, 5, 6, 6, 1, and 6, 5. Okay, we end up until 11. Okay, so because 13, the highest numbers on the dice is 6, so 6 plus 6 equal to 12, so it won't reach 13 here. Okay. So now, how many are all of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So the number of event of B equal to 15. So then the probability of B equal to 15 divided by 36, or we simplify it as then we get 5 divided by 12. Okay. Then example 7, there are 100% of Form 6 students, who 20 are studying biology, 15 are studying chemistry, and 8 studying both biology and chemistry. So we can illustrate this in a Venn diagram. So let me introduce you what is Venn diagram is. Okay, this is the one. Okay, now this is a 20 are studying biology and chemistry. According to that, here B biology and C chemistry. So now 20 are studying biology, 15 are studying chemistry, and 8 are studying both biology and chemistry. So in the we call the student that study both is 8 here. Okay. Are we going to write down 20 according to the statement? Are we going to write down 20 here? No. This is 20 minus 8, which is equal to 12. Okay. 20 of students studying biology is all this. Whole of this circle is for the students studying biology, 20, all of them. But then among those 20, 8 start taking biology and chemistry. So those students taking biology only equal to 12. And this also, same thing goes to this one here. So 15 minus 8 equal to 7. So B stands for students who taking biology, and C for those taking chemistry. Okay, now the probability of student studying both biology and chemistry equal to the numbers of students taking biology and chemistry divided by number of S here, or the whole student, which is 100, equal to 8 divided by 100, or 0.08. Okay. And then, if the question wants you to find out the students either study either biology or chemistry or both, okay, let's say if I clear this first. Okay, if question wants us to find out the probability of students taking biology or chemistry or both. So then this is a probability of B union C. Then it is 12 this one here, plus with 7 here, plus with both taking biology and chemistry, which is equal to 8 divided by 100. Or simplify this, it gives you 27 over 100, or it is 0.27. Okay. Okay, so we reach what we call the end of our lecture here. For this exercise, I think that I let all of you to try the question by yourself. Okay, so for this one here, let me give you the answer then. Exercise, a solution of this. For this one here, which is 1 over 4, at least one head equal to 3 over 4. Okay. So these are all the fun answers. You may try the question by yourself. That's all for today. We'll meet again in our next series of our lecture here. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.